So in this lesson, I'll be covering nature of fruits, and I'll be showing all the tips and tricks and all the hacks that you need to know to understand this topic fluently. By the end of this lesson, you should be able to tackle any nature of fruits question. And usually this question, really the section is usually assessed under functions, in most cases, sometimes under algebra. But I'm doing it here so that you really have the background of it in a more detailed fashion. So when they talk about nature of fruits, really it's nothing really that should be foreign, because we're really looking for when you're given your quadratic equation as minus b plus minus the square root of b squared minus 4ac all divided by 2a. So when they're referring to roots, really they're referring to these under the square root here. This really gives us the roots of a quadratic equation. And remember, the a, b, and c comes from ax squared plus bx plus c. So when we're talking about the roots, we're talking really about the value that b squared minus 4ac will give us. So when you say nature, we're actually describing the types of roots. And really we use really a symbol called a discriminant to describe the roots. So whenever you see a discriminant, right, or the triangle, you should know that we're talking about b squared minus 4ac. So when you say nature, we're trying to describe the characteristic of this discriminant. So if you look at this really table constructed here, it summarizes everything. This table is a lifesaver and it's a hack. So it's everything you need to know in nature of fruits. So if any question speaks about something being real, it means that the discriminant is greater or equals to 0. If a question asks you for roots that are real, equal, and rational, know that the discriminant is equal to 0. Real, unequal, and rational, the discriminant is greater than 0, or it equals to a perfect square. A perfect square is 4, 9, 49, and so on and so forth. And real, unequal, and irrational, it's greater than 0 or not equal to a perfect square. And non-real, imaginary, it's less than really 0. So memorize this table and understand it really. So let's go and try really and tackle some questions. We start with really basic questions and we'll build up our knowledge as usual. So the first question, we are asked to determine the nature of fruits of the following. So we are determining the nature of fruits. So we're giving that x squared plus 6x plus 9. We need to determine the nature of fruits. It means that we need to calculate what our really discriminant is, right? We need to find out what our discriminant is. So we need to know that our a is 1, our b is 6, and our c is equals to 9, and our a is coefficient of x squared, our b is coefficient of x, and our c is the constant. So we really need to calculate what our discriminant is. So our discriminant, we know that our discriminant is equals to b squared minus 4ac. So we need to substitute and calculate what we get. B 6 squared minus 4, our a is 1, and our c is 9. So we need to calculate what value we get when you calculate that, or when you punch that into a calculator. And if you quickly punch that into a calculator, you'll see that we get a value that's equals to 0, meaning our discriminant is equals to 0. So once we've calculated what our discriminant is, we go back and look at our table. So in what situation is our discriminant 0? We see that our discriminant is 0 really when our roots are real, equal, and rational. So our answer will be what? Our roots will be real, equal, and rational. And that will be our full answer. We calculated what the discriminant is, and really we described it as to what it is. And that will be the solution. So we move on to the next question, which is the same. We are asked really the same under the same main question. So determine the nature of fruits of the following. So in this case, we're given two brackets that are multiplying each other, x plus 5, x minus 6, but we cannot determine the nature of roots or calculate the discriminant when this is in this form, so we just need to really FOIL the brackets out so that we have our quadratic equation, which will be x squared, x by x squared, x by minus 6 is minus 6, 5 by x is plus 5, minus 6 plus 5 will give us negative x, and then we multiply 5 by 6, and the signs are opposite, so it will be negative 30. So now we need to calculate what the discriminant is. We know that our a value will be equals to 1, our b value minus 1, and our c value will be equals to negative 30. Discriminant is equals to b squared minus 4ac. Our discriminant will be equals to, our b value is minus 1 squared minus 4, and our a value is 1, and our c value is negative 30. So we can quickly calculate what value we get from there by punching everything into the calculator, or really you can do your mental maths, and you'll get that you're gonna get total value of 121. Our value is equals to 121. So we go back to our table, look at our table. We got 121. So definitely our value is greater, or equals to, it's greater, but it's not equal to 0. So it can't be real, right? It can't be exclusively real, but our value is greater than 0. But is 121 a perfect square? You can check that by saying the square root of 121. If you get really a whole number, then it is a perfect square. So you can see that our value is 121, which is greater than 0 and is equal to a perfect square, which means then really our roots will be real, unequal, and rational. So the roots will be real, unequal, and rational. And really that's how you would have calculated or determined the nature of roots. So what we did here, we calculated what our discriminant is, and we described what the nature of roots is using really our table here. That's why I'm saying this table is a lifesaver. So let's try and move on to the next set of exercises and see how we can also further build our knowledge on nature of roots. So in this case, we're given the question where we ask for which values of k will the equation x squared plus 4x is equal to negative x have. First question we asked is equal roots. So we are asked on equal roots. Equal roots. The second question, unequal and real roots. Third question, real roots. Fourth question, non-real roots. So what you need to know in this type of question is that we are given the equation, the quadratic equation, 4x is equals to minus k, and this can be written as 4x plus k. So you're not supposed to really panic when you see this. It's nothing more than a quadratic equation where your a value is 1, your b is equals to 4, and your c value is equals to k. Right? So we're going to be using really all this background information to answer all these questions. So the first question, when are the roots equal? So we need to find the value of k for which the roots are equal. So when are the roots equal? The roots to be equal, it means that what? The discriminant needs to be equals to 0. That's when the roots will be equal. So we're going to use this to calculate the discriminant, and our discriminant needs to be equal to 0. So it means b squared minus 4ac should be equals to 0. And what do? We substitute b, a, and c. Remember, we calculated what our b, a, and c were. So we just substitute our b value, which is 4 squared minus our a value is 1, and our c value is k equals to 0. Remember, they're asking us for the value of k. So it means we need to solve for k. what we'll have is negative 4k. 16 minus negative 4k is equals to 0. So we can take the 4k to the other side of the equation, and we can divide both sides 4, and you'll see that 16 divided by 4 is nothing more than 4. Therefore, for the roots to be equal, k needs to be equals to 4. And that's the answer for the first question. So if we move on to the second question, we are asked about something interesting. We are asked, when will the roots be unequal? Real roots. Unequal real roots. When do we get unequal real roots? So unequal real roots, we know that it needs to be, the discriminant needs to be greater than 0. They're not telling us or asking us whether they're rational or irrational, but since they are unequal and real and unequal and real, it's the same equation where the discriminant needs to be greater than 0, and they're not specifying whether it's rational or irrational. So therefore, we know that our discriminant simply needs to be greater than 0. And we know that our discriminant is b squared minus 4ac greater than 0. Do the same thing we did in the previous. We just substitute our b, which is 4, minus 4, and our a is 1, and our c is k. Remember, it needs to be greater than 0 because we're looking for unequal real roots, and we solve for k. It will be 16 minus 4k is greater or equal to 0, and we take the 4k to the other side of the equation to be greater than 4k, and we divide both sides by 4k. And if we divide both sides by k, it will be 4 is greater than k. Okay, is less than 4. Either or. Solution is valid for either situation. Then we move on to the third question. You can see now that it's following a similar or same pattern, right? It's starting to be monotonous. And once math starts being monotonous, it means you're on the right path. It means that you are nailing the basics. And they're asking us for real roots, only real roots. For only real roots, you can see real roots, it's when the discriminant is what? It's greater or equals to 0. So we know that our discriminant needs to be greater or equals to 0. That will be b squared minus 4ac is greater or equals to 0. Our b value is 4 squared minus 4, a is 1, and our c is k, greater or equals to 0. We know that it will be 16 minus 4k is greater or equals to 0. And we can take the 16 to the other side for a change. Greater or equals to 0 to negative 16. We divide both sides by negative. And the inequality sign changes when you divide or multiply by negative. K will be less than or equals to 4. And that will be our answer. Solution for number 3. And we can move on to number 4. Let's try and do number 4. See what we get for number 4. Let's just remember that our a value is 1, our b is 4, and our c is equals to k. So we're just jumping into number 4. Number 4, non-real roots. Non-real roots. Where or which are non-real roots? Non-real roots are non-real imaginary roots. It means that discriminant is less than 0. The discriminant is less than 0 means b squared minus 4ac is less than or equals to 0. Our b is 4 squared minus 4. A value is 1 and our c value is k. So less than 0, which will be 16 minus 4k is less than 0 minus 4k is less than minus 16. You divide both sides by -4. Inequality sign changes, and k is greater than 4. And that'll be the solution. So you can see we follow the same chain of thought, referencing this table and calculating the values of k when needed. So really this is just a summary and really the foundation of how to nail nature of roots. If you understand this table here, I wish to show you there's no question on nature of roots that you'll get wrong. And that will be the lesson on nature of roots today.